Okay, it's time to get started, so I'll go ahead and kick things off. This is Becca Kwan, by the way, with DLF. This is the main meeting of the DLF Museums cohort. Welcome back to those of you who are regulars, and to those of you who may be dropping in for the first time. We're really glad you're here. I'm sorry if there's background noise. I'm at a conference and just sort of found a little corner. So a couple of administrative notes. The link to the agenda is going into the chat box right now. Please add your name to the list of meeting attendees at the top. Today's session is going to be recorded, so I'll drop the link to the recording at the top of this document within the next couple of days if you want to rewatch or share it with someone. And then today's meeting will build on some of the discussions we've been having in the past couple months about born digital collections and the tools that we use to work with them. I'm really excited that we are able to welcome Christopher Cowley to the meeting. He'll be talking about BitCurator. Cal is a professor at the School of Information and Library Science at UNC Chapel Hill. His primary research focus is the long-term curation of digital collections. He served as principal investigator of the BitCurator, BitCurator Access, BitCurator NLP, RayTome, and co-PI on OSS ArcFlow projects, as well as several projects focused on digital curation education. Cal's a fellow of the Society of American Archivists and serves as editor of American Archivists. And I think he'll be doing a presentation and then taking questions at the end. So I'll hand it off to you, Cal.
Great, thank you. So I hope everybody can hear me okay.
Yeah.
Yep, you sound good.
Hello, excellent. So yeah, I have some sort of prepared remarks, and then hopefully we can have a fairly active discussion around all of this, how this might be relevant to things that you're interested in. I wanted to start out by just with a little motivation for thinking about the goals that libraries, archives, museums, cultural institutions have when acquiring materials. We want to ensure their integrity, allow users to make sense of them in terms of the context that they sit within, and also preventing inadvertent disclosure of things that might be sensitive, whether they're related to donors, related to people associated with records or objects in museum collections. And the same fundamental principles really apply. We have issues of provenance, making sure that we know where things have come from and what activities they're associated with. From an archival perspective, there's the notion of original order, making sure that if records were kind of managed and associated with each other in a certain way, that can be reflected over time. And then also chain of custody, making sure that either things haven't been changed at all over time, or if they have been changed, that there's a obvious succession of steps that have been documented in terms of what's been done. But given all of these principles and objectives, what about when collections look like this, right? So this is an example of some materials from Andy Warhol. It includes not only hardware in terms of keyboard and computer and various associated documents, but also floppy disks, right? So what's to be done when the materials are actually sitting on external media that need to be copied and used in new computer environments? Or when papers, that is in quote, right, anything that comes from, whether it's an artist, an organization, an individual, or the records from institutions, whether that's, for example, within the institutional records of a museum or records that have been acquired as part of a larger collection, come in these sort of forms, when they're hard drives from an entire environment, whether they're floppy disks, flash drives, optical media, whatever they might be. And so that's a really big motivation for the work that I'm about to talk about. Tying this into objectives of museums, this is from, I'm sure many of you are familiar with this book, Recollection. John Ippolito says in one of the sidebars to the book, what we really need from museums of the 21st century is not their expertise in building climate-controlled vaults, but their practice in reconciling multiple interpretations. So what I'm going to talk about a little bit before I dig into what the software actually does is some of the motivation in terms of that idea of multiple interpretations and the fact that information can reside at different levels in a digital environment. So we can think of digital information residing at a variety of levels, ranging from all the way up at aggregates of objects, sort of collections and series and things like that, down to objects or packages that it might be composed of a variety of parts, to how they're rendered in a particular application, to the file through the file system. So this becomes important if something comes off of a medium and you care about things like timestamps and directory structures, so that the file doesn't end up getting just treated like a discrete object. The file as a raw bitstream can be important in a lot of museum contexts where we care what the composite structure of the actual file is in terms of the bytes within it. And sometimes what really matters is the component structure of the file and not the file itself, right? That's just a kind of useful container from a computer science perspective, but we care about something that involves a component element of that. There's the bit stream through the input-output equipment. So that's the bits as you're reading off. You know, let's say you had those discs from the Andy Warhol collection and you wanted to be able to replicate what's on that disk. If you just read the ones and zeros off of the sectors of the drive and write them to a file, we call that a disk image. There's also then the raw signal stream through the input-output equipment. So that's before the equipment involved even interprets it as ones and zeros. There are physical analog properties that are, you know, floating through the air or through wires that we have to be thinking about. And then ultimately there's the bit stream on a physical medium. So if we look at just each of these in turn, here's an example of an aggregation of objects, right? This is using a tool called Context Miner, someone running the software, searching for materials related to a given context. In this case, it was, you know, a previous US election, queries related to names of people who had been running for president at the time. This isn't showing you the objects, it's showing you in the aggregate what they look like as a set of objects. You could then step into the individual artifact itself and say, not only do I want to know what that object was, but what is its associated metadata components that are part of the package around it. You might want to know how it would have looked in a particular application. So for example, you know, a video in a flash viewer in a browser. And obviously in a lot of museum contexts, especially when it comes to artifacts coming from, you know, artists or other creative works, it can be very important to know how it might have been rendered and experienced in a particular setting. There's the file through the file system. So this is looking at metadata associated with a file that might have been pulled off of a disk, for example. If you simply copy the file off without getting to that associated metadata, you're not going to get that full representation of that contextual information. You can look at the bit stream, which is essentially well, you know, the ones and zeros within the file, but generally interpreted actually as bytes just for human readability. So in this case, you can see a hex editor where on the left side are each of those two sets of numbers going from 0 up to F, 0, 0, 0, 5, 1, 6, are a byte of information. And then on the right, you see what that would be as an ASCII text representation. This is an example of a Microsoft Office file that you've opened as a zip file, because Microsoft Office, for anyone who uses Pages on a Mac or uses LibreOffice and then saves things in the native formats for LibreOffice, you may or may not be aware, but the files that you're creating are actually just zip files. And so you can open them up and look inside of their components if you open them with a utility that can look at zip files. All right, this is a different level of representation, and there might be interpretations people want to apply by looking inside the file at this level, but that's an important curatorial decision. Then there's the bit stream through the input-output equipment. This is showing a tool called Guymager running in the BitCurator environment, creating one of those objects called a disk image, where it's going through all the sectors of the disk and writing them out to a file. There's also, again, this raw bit stream before something is interpreted as ones and zeros. So if you're as old as I am, you may recall, or maybe you've just read in some history books, that we used to store data not just on floppy disks, but on cassettes, which are similar in form factor and composition to the exact same cassettes that you would use to listen to music in those days. So then if you're trying to pull that data off of that cassette, you would need to first generate what you see in the middle of the image here, the actual analog audio stream, you know, the squeaks and buzzes coming out of the speaker. And then you have to then interpret that as ones and zeros, as a set of discrete values that are either high enough to be a 1 or low enough to be a 0. And then finally, you have the actual physical composition of the disk. So you see here the surface of a hard drive, the surface of a CD. So there are definitely cases in a museum context when we care a lot about the artifactual nature of the physical medium. You want to keep a disc around to put it in an exhibition to be able to show what the disc looked like. But the risk of relying solely on that disc for access to the data is it's going to become unreadable over time, right? So part of what the BitCurator environment is helping with is sort of stepping up to those higher levels of representation and extracting the information so that it can still be usable on later technologies. So libraries, archives, and museums have in recent years been adopting a lot of things that have been previously associated solely with the field of digital forensics, using things like write blockers to make sure that data doesn't get changed when you plug it into your computer, generation of disk images, which we've just been talking about briefly, applying cryptographic hashes, so these checksums before and after the files have been transferred or stored so that you know whether they've been changed, capture of what's called digital forensics XML, and I'll very briefly show you what some of that output looks like. And also scanning for personally identifiable information, right? This can be very important when there might be materials that were part of a collection, but the donor or other stakeholders didn't intend to share with the world. But there is need for adaptation in cultural institutions. One thing is adaptation to the workflows that actually matter to libraries, archives, and museums. Another is treating the metadata as something that should actually be cared for in a very consistent and systematic way. Digital forensics as a field doesn't really care inherently about the metadata. That's just something they have along the way to generate things like reports that might be used in court. But for those of us associated with collecting institutions, the metadata itself can become an extremely important thing for us to manage in a particular way. Provision for public access to the data, because in digital forensics as a field, they're using evidence to prove something in court, for example. That's not something that's going to be shared widely within the gallery of a museum or within the reading room of a library or archives. And then also support for older technology. So floppy disks, for example, are no longer a primary concern of the digital forensics field. HFS and now HFS Plus, which are both older file systems for Macintosh environments, now that Macintosh has moved to APFS as its file system. So we've had a couple of reports that came out of the original project that the Andrew W. Mellon Foundation funded for BitCurator. One was called From Bitstreams to Heritage, putting digital forensics into practice in collecting institutions. And another one was called From Code to Community, which was looking more at the professional and institutional issues about how do we actually care for and perpetuate the use of this software as opposed to just developing it. So the BitCurator project itself ran from 2011 to 2014. It was funded by the Mellon Foundation. The partners were SILS at UNC, where I reside, and the Maryland Institute for Technology and the Humanities at the University of Maryland. These were the people involved. So myself, Matt Kirschenbaum, Kyle Bickoff, and Amanda Visconti, who were at Myth. Then also Cam Woods, also Porter Olson, who was at Myth, then Cam Woods, Alex Chasanoff, and Sunita Misra at UNC. We also had two groups of advisors, a professional experts panel and a development advisory group, and you can find out more about them on the website for the project. The goals were basically developing an environment for collecting professionals, right? People in libraries, archives, and museums that incorporates the functionality of open source digital forensics tools, but addresses those needs that I had just said that the industry of digital forensics itself doesn't really address. Incorporation into the workflows of our institutions and support for us being able to provide public access. So the environment is a Linux operating system. It's an Ubuntu Linux operating system that has been customized in a variety of ways. It has special software embedded into it that you wouldn't normally find in Linux. And it has a lot of customizations in terms of what happens when you right-click on a file, for example, that have been built in to support the kinds of activities that people in libraries, archives, and museums are most likely to engage in. It can be run as just its own Linux operating system installed on the computer as that computer's native operating system, either as a separate partition or the only partition on the machine. That's the most efficient way to run it, but there can be limitations if people are in institutions where that's not really supported. You can also run it as a virtual machine, which means that you can run it on your own computer if you have enough memory and storage space. If you have a Macintosh or a Windows laptop and you want to run it to experiment with it, you can install VirtualBox, then install it, basically add it as a virtual machine to VirtualBox and run it that way. or there are a variety of individual components from it that you could just pull out and use individually without running it as a self-standing environment. These are the basic parts of the workflow that it supports. Acquisition, meaning getting data off of removable media. Reporting in various ways about what was found on the media. Redaction, so identifying things that might be sensitive and flagging them for either removal or filtering. And then export of a variety of types of metadata. So what I'll do is just kind of walk through very briefly what those aspects of the functionality are. This is what the desktop looks like. If you're not familiar with Linux, it shouldn't be very hard to get started in the sense that you know, the sort of set of icons to the left is very much like the dock in Mac or the taskbar in Windows. It's where the various applications are that are running or that are you know, sort of set to be bookmarked to be quickly available. There are folders on the desktop that have various applications built into them. And we'll walk through just a few of them now that might be likely to be relevant to you if you're getting started with the environment. Before doing that, I wanted to point out what sustains the software. I pointed out that 2014 was the end of the original grant-funded activity, so that was 5 years ago, but the community continues to thrive. And that's because there's a consortium in which institutions pay membership dues. This doesn't get them access to the software itself, because the software and the documentation are free and open source. Anybody who wants to download and use them can. What it gets them is participation in kind of setting of the direction of the software. They get access to a dedicated help desk to answer technical questions. They have access to some webinars and things that we do that are specifically targeted to consortium members. And they also get things like, we have an annual event, so we have coming up at Yale, the BitCurator user forum that happens every year, and institutional members get a discounted rate for access to that. And this is just the website for the BitCurator Consortium. I should say I accidentally included the old URL here on this slide. It's just bitcuratorconsortium.org, so that's where you should go if you want to find out more about this. So here's a list of the current members as of today. And this was just to highlight several of the institutions that are either, you know, museums themselves or are institutions that have both museum and archival functions. So even though predominantly a number of the members are libraries and archives, there are also a number of museums that are part of this consortium that are, again, setting the direction of the software, acting as sort of representative users of this environment to set its future direction and advance the discussion and use of it. So now let's look just at a few specific curatorial actions and processes. The one thing in the background to be aware of is write blocking. This is, as I had mentioned before, making sure that you don't inadvertently write something to a disk. If you attach it to the machine, it's only going to read data off and not write it to the device. You might think that's not necessarily because you're going to be very cautious and not click in the wrong place. The reality of contemporary operating systems, whether you're in Windows or a Mac, is the moment you plug in a device, your operating system is going to want to start writing data to it, which means it's going to be overwriting unallocated space. It's going to be making changes to the disk. So if you care about the integrity of the disk in terms of the bit stream that was on it when you first encountered it, you want to make sure that you use write blocking. And there are a variety of ways to do this. This is showing the Ultra Bay, which is the part of a FRED. It's a forensic recovery of evidence device. It's a computer that's used for forensic acquisition. You can also see at the bottom of this image the Tableau and WeBTech write blockers. So those are dedicated little devices that, you know, there's nothing particularly exciting or advanced about use of them. It's just the awareness that that plays a role in making sure that you don't change the data. So you would plug into one side of this device the disk that you're reading from, and then plug it into the other end to connect to the computer that you're actually reading from. So this is showing a 5 1/4 inch floppy disk. If you have floppy disks that are of this older generation, 5 1/4, if light can get through, it's not write protected, which means you need to cover up that write enable notch. On a 3 1/2 inch floppy disk, it's actually the opposite, which is if light can get through, it is write protected. So you want to make sure that you flip open that little window so that you can see through it. Also in the BitCurator environment, we have a set of rules set up so that you can switch on or off whether you want every time you attach a device for it to be readable only or readable and writable by default. And so that's something that's built directly into the environment. Another thing that a lot of people do in the BitCurator environment is create disk images. So a disk image is a way of copying every sector off of the disk rather than just copying the files through the file system. So in our everyday use of a device, if I plugged in a flash drive to my computer and I wanted to get the files off it, of course I would just right click, copy, paste them to my computer, and that's perfectly fine. But if I care about the underlying structures of the timestamps, potentially hidden system files, unallocated space that was there from files that have previously been deleted, any of that information will be lost if you just copy the files. And so when those things are a consideration, creating a disk image is the most important course of action. And there are some commercial tools that do this. There are free but commercial tools, and then there are also free and open source tools like Geimager, for example, that runs in the BitCurator environment. So here you can see the interface. You can see from the language that obviously it's been borrowed from the digital forensics world because it has placeholders for things like case number, evidence number, examiner. But obviously when people are using these in cultural institutions, they simply swap that in for, you know, the curator or whatever it happens to be, acquisition number, collection ID. If you want to see information embedded in a disk image, if this has been a packaged disk image using, for example, the file format called expert witness format, in the BitCurator environment, you can right click on the file, indicate scripts, disk image information, and then show EO1 information. And what this shows is essentially provenance metadata. It's showing how was this disk acquired, when was it acquired, what is the checksum showing how it was actually acquired. And that information with this format of disk image actually gets embedded right down into the file. There are 4 ways to interact with disk images. You can use emulation, which is certainly an important modality for many museum collections. You can mount them like regular drives. So you basically, you know, you use a tool that then translates that file to treating it like a disk that's been connected to the computer. You can also inspect them as forensic objects using something like FTK Imager, which is a free but proprietary tool, and also the disk image access tool that's been built into the BitCurator environment, which we'll look at in just a second. And then finally, you can also navigate through the content of a disk image within a browser using a set of tools called BitCurator Access Web Tools that we developed in a project also funded by the Mellon Foundation, but that followed on from the original BitCurator project. So just looking at these very briefly, if you're not familiar, there's a service called Emulation as a Service that was developed through a team at the University of Freiburg. It's now most recently been spun off as a separate startup company. With the same team associated with the leadership of that company. And the idea is that if you need to emulate an environment, if you have an old artifact that you need to bring up in an old Macintosh computer, you could emulate that platform, bring up the operating system, and then just open the file within that operating system, right? You encounter it just as you would have in the original computer. Another use of emulation is to bring up a file in an old application simply for purposes of converting it. You might want to bring it up because you know that some older version of PowerPoint, for example, is able to convert to a format that you are able to read, but your current version of PowerPoint can't. So you could bring up an older operating system with that older application and do that conversion. Another way, as I had mentioned, to interact with the disk image is mounting the image using a mounting script. So in the BitCurator environment, this is as simple as going to scripts and then mount disk image, and then it will show you the contents of the disk, just as if you had just attached it as an actual physical device to your computer, but without any of the risk of dealing with an old floppy disk that's not going to be readable forever. You can also export files from a disk image using disk image access tool, which is shown here, where you can see the contents of the disk image. The entries that are red there are deleted, so that means you can see things that are in unallocated space that might still be recoverable because there's a directory entry associated with them, even though a typical end user who had mounted this disk wouldn't see those entries because they're masked from view. This is then the BitCurator Access Web Tools. If you're interested in this software, if you want to run it locally, you can check it out on our development server here. If you want to actually run the software somewhere else, you can follow the instructions available at this GitHub. The idea is basically you take disk images, you put them into a directory, and then the end user doesn't need any of these other specialized tools. They don't need to have the BitCurator environment, for example. All they need is a web browser. They can then visit that collection, and you can see how they're grouped in various ways, and then they would be able to navigate down into the contents by going folder by folder by folder down into a file. Then finally, what they could do, if they click on either the file download, they'll just download the file. They can click on the text output, which you see on the left side here, which shows you just the ASCII text that might have been embedded in the file. And then finally, they can do entity extraction, where it will run natural language processing software that pulls out identifiable entities like dates, names of people, and organizations. I will say that this is, for purposes of convenience, a bit of a Frankenstein image. You'll never see this combination on one page in the tool because that text output and an entity output are actually two different views, but I've included them right here just for convenience. Another thing that people do a lot of in the BitCurator environment is run a tool called Bulk Extractor, which was developed by Simpson Garfinkel. This will scan for personally identifiable or other potential sensitive information. It will look for things like email addresses, geo coordinates, right? Because there might be GPS coordinates that are from an image taken on a phone that you might not want to be disclosing. It'll look for things like domain names, encryption keys, phone numbers, social security numbers, credit card numbers, things that might be sensitive that you didn't realize simply by looking at the rendering of a file were contained within it, and then you can make decisions about what you'd like to do with it. This is what's called Bulk Extractor Viewer. So this is viewing after running the Bulk Extractor tool, what the output looks like. So this is a histogram of running Bulk Extractor against an entire disk and then seeing every single email address that appears on that disk. In this case, there were 12 instances of this privacy@motorola.com, and then you can jump down to the individual instances to see in context where it actually appeared. There are then also a variety of other reports that people can run in the BitCurator environment that will not just show you, for example, what are called features, the things that Bulk Extractor found, but also tell you where they are in terms of the directory structure on the disk. It'll output all the information about all the files and folders, what their names were, what directories they were sitting within, how big the files were, what their timestamps were, and then it kind of associates all that information together so that you can have reports that tell you, for example, I found this credit card number and here's the specific file that it was within. One thing I'm not going to talk about in this webinar now, unless people have questions about it, is an additional tool that we've developed called the PDF redaction tool, which will allow you to then, given this output, go into a PDF file, identify the different instances of that particular string, and make a determination about whether you want to ignore it or redact it. And if you redact it, then when you generate the derived PDF file, those little strings will be fully redacted, right? There'll be a black box over the text, but then the underlying text will also be removed. This is showing provenance and technical metadata. So when these tools run, they output information about what the tool was, when it ran, how it was compiled and what version was used, what the specific command was that was issued, and then also information about the disk, partitions, block sizes, all these things that are fairly low level but can be important for sort of technical dependency perspectives. This is then primarily what people care about for the DFXML, as I mentioned before, for digital forensics XML. When you run these tools in their default settings against a disk, the FileWalk tool will go through and identify every file and directory, whether that's a deleted directory entry or one that's been allocated so it has a live file associated with it, and output a variety of these metadata elements. Is it allocated, meaning, is it a deleted file or not? What's the file name, including its full path, if it was in a directory structure? What are the timestamps? The byte run indicates which sequence of bytes it's actually stored on the disk, so you can find, physically on the disk image where you would find the content of that file. It tells you what kind of file it is, and it generates these hashes, which are the checksums for the files. If you're interested in what all these elements mean and how they're being characterized, there is a schema for DFXML that's available at this URL. Alex Nelson, who works for NIST, is the primary keeper of it. You can see his name there on the GitHub repository, but there's a group that maintains this schema that includes Cam Woods, who I mentioned before, who's been the technical lead for all this work. There is also premise metadata. If you're not familiar with premise metadata, the quick summary is that it's preservation metadata that has different categories of metadata. Metadata about the agents that carried out actions within an environment, the objects, the rights associated with them, and then the events. So the idea is that you can do this sort of chain of custody by indicating, I took this action on this file, and here's a little snippet of XML that tells you what action was taken, right? So this metadata is also generated by these various reports. And there are a variety of other specialized reports that get generated when people run those reporting tools. Things like this little bar graph that shows you what kinds of files were on the disk, right? So you can get a quick characterization and say, oh, you know, the vast majority of these were PDF files, and there are a long tail of some others that are of different formats. Also statistics about, for example, when bulk extractor ran, how many different kinds of potentially sensitive information did it find? Did it find them in unallocated space, meaning deleted files, or did it find them in allocated space, meaning live files? All of those things get output as reports. Some of them are directly human readable, some of them are intended to be more machine readable. When both are important, it generates both. So for example, there's some outputs that are these tab delimited, pretty ugly to look at, but machine readable files that are also then represented as an Excel spreadsheet, so they're easier for a human being to navigate through. There's a variety of other tools embedded in this environment that I'm not going to be talking about, but I just wanted these up on the screen for people to see, to be aware in case you had questions or comments about particular use cases, kinds of file formats, kinds of tasks that you're wondering about. They range from dealing with particular activities that you might use to act on a file or an image to very specialized kinds of data you might be dealing with. Like, for example, read PST is focused on PST files, which are email from Microsoft Outlook, right? And here's just a variety of other tools that are in the environment. We basically use these criteria where it has to be an identified user need that then makes, that's one of the thresholds for it getting added into the environment. We don't want things there that are just extraneous. It has to be something that we've found that's mature, stable, and open source, because we're not going to put something into the environment that's proprietary. And it has to be something that doesn't end up having such a massive dependency footprint that it makes the virtual machine too huge, right? So there are some tools that get used in the environment that are more a point of discussion within the community, but they don't get embedded by default into the environment because they would just be too big for everybody to have to download. So I wanted to wrap up by just pointing out how some of these things have been incorporated into digital forensics. How some of these digital forensics activities have been incorporated into library, archive, and museum workflows. There are a variety of sources you can go to find these workflows. The first that's cited here is Marty Gegenbach did a study. He did a master's paper study back in 2012 in which he interviewed people from various institutions who were incorporating these digital forensics methods. And he mapped out their workflows and then did a prose, just a textual description of them, and then also graphic representations of them, which you can find within his paper. The AIMS project, which was also around that same time, 2012 is when it wrapped up, had a white paper that shows a variety of workflows. MIT, the Digital Sustainability Lab there, so Kari Smith, Nancy McGovern have some very well thought out, broken down workflows that they have also demonstrated that include digital forensics elements. The BitCurator consortium itself has workflows that are shared through the website. And then there's also been the OSS ArcFlow projects funded by IMLS. So each of these are just placeholders. Obviously, this is ugly on the screen for you, and I'd recommend if you're interested in these to go to the source and you can see them in much higher resolution and detail. But this is an example of, at the Beinecke at Yale University, their workflow at the time in 2012 when Marty did his study. This is the University of Hull from the AIMS white paper. This is a representation of a part of the workflows that have been elaborated at the MIT Digital Sustainability Lab. And this is where you can see the various workflows that have been shared through the BitCurator consortium. You can see a couple have been reserved for members only. So that's because of the arrangements that the institutions were comfortable with. They're going to share them with member institutions, but not with the general public. All the others you can just click on and see. And then finally, we've had this project that's just starting to wrap up now from IMLS, which is a partnership between UNC SILS, where I am, and the Educopia Institute, to look at the workflows of different institutions that are incorporating archive space, Archive-O-Matica, and the BitCurator environment. So 3 different open source environments. These are the institutions that have been involved. There's a fairly broad representation of institution types. They are all US, so there's not an international representation. Though I should say that actually the National Library of New Zealand has taken up the exact same mechanisms that we've used for representing workflows, and it's now how they're using their tools to represent the workflows that they have there. So if you look at these, you'll basically see this workflow that goes from left to right. The top is whether Archive-O-Matica, ArchiveSpace, or BitCurator is a tool that's used at that point in the process. So you can see the little dots. The bottom is the people involved. So if somebody is involved in that task, there's a dot to indicate their involvement. So for example, if there's a handoff between a curator, let's say, of a collection to a technician who's going to do a lot of work around it, and then it comes back to the curator for some description or decision making, this can now be much more explicit and illustrative to that curator to know what are all these steps that happen between when I hand this thing off to you and when it comes back to me. So for further information, bitcurator.github.io has information about the various component projects of this larger set of activities, including the original BitCurator project, BitCurator Access, BitCurator NLP, which I didn't really talk about in detail. Our most recent project is called RATOM, that's focusing more on email preservation, retention, and processing. And then finally, the BitCurator Quick Start Guide is the best place to get started using the software. So it goes from the very initial set of stages of how do you kind of download the software and add it either as a virtual machine or set it up as the operating system to a computer, to working through these various steps that I just presented to you in terms of generating reports. It'll have screenshots and work through textual descriptions of what those outputs are. So those are my prepared remarks. I'd be very interested in either clarification questions people have, thoughts about how this might be applicable in environments that you're aware of. So, anything's fair game. I'll stop sharing my screen and I'm happy to entertain, questions or comments.
So I'll go ahead and ask a question.
Of course, yeah.
Would you be able to tell us a little bit more about the BitCurator Consortium and where people might want to start exploring if they're interested in becoming part of that community?
Yes, definitely. So, so there are several things, right? So again, it's just bitcuratorconsortium.org if you want to go to the website. And I had, of course, highlighted the handful of institutions that are more, museums or museum-oriented kind of activities. Those are all membership commitments, right? So each of those institutions have paid $2,000 a year. They've joined, they've gotten listed as institutional members. So certainly if you're associated with an institution, you're using the software, you care about the future direction of it, you want some of these other benefits like, being part of the help desk, getting discounts on certain activities, being part of different webinars. The mechanism to do that is basically for the institution that you're associated with to join as an institutional member. We now have 43 members across 4 different countries, right? It's a very kind of continuing to grow and very active community. A step removed from that, but also an extremely important step, is activity that doesn't involve actually joining that consortium. It has a lot of very important benefits, and it's vital to the future of the software that there are a lot of institutions that pay in and are active members of that consortium. But we also have the BitCurator user list. So you can find that if you go to that, the GitHub that I was pointing you to before. You can go to, it's basically a Google group, right? You can subscribe to it if you want to get things pushed to your email, or you can just check it out periodically by looking at it through the web interface. That's completely open to anyone. You can pose questions there. You can see the sorts of things that people have been discussing. There's also, again, this user forum that's coming up pretty soon. If you look on the consortium website, you'll see information very prominently about the user forum that's coming up. That's open absolutely to anyone. There's a discounted rate for consortium members, but it's open to anyone. And that's a 2-day event. It grew out of the project itself, and we had several of them in Chapel Hill, which is where the original project was based. We've had one in LA, we had one at Northwestern in Illinois. So it's really moved around nationally. And that's a place where you can really, starting from, very entry level, I want to just figure out how the software works. And, the first day has recently been dedicated to an introductory workshop, to much more advanced, I've got this multi-step workflow and I'm trying to talk with my colleagues about how I might vary this one step of what I'm doing, right? So kind of everything is fair game within that group. So those are the primary ways to get involved. Certainly if you're just looking for sort of direct connections with those who are involved because you think that, you know, those kinds of interpersonal connections are the best way to get started, which often they are. You can look to the names of the institutions that are members of the BitCurator Consortium. And if, for example, you know, the people at the Smithsonian Institution, for example, if any of those are people you know, or you know people who know them, right, you can follow up with them as context to sort of see what their experience has been and compare notes with them about how they're using this software. But those are some ways to get involved, right? And both of those spheres of activity are incredibly important to this work, that there has to be this consortium that actually, because it's open source software, that has to be maintained. There's a community around it. You know, the documentation has to be regularly updated. That has to get funded somehow. So the consortial members really fund that. And again, they help to set the direction of what's going to happen with the next release of the software, what kind of training is going to be there. But there's this much wider sphere of people who are students, faculty, you know, people working in smaller institutions who haven't paid in to be members, but are still part of this larger user community. The context largely for this webinar that we're doing right now is the BitCurator EDU project. So that's another project also funded by the IMLS, and that is to reach out to schools, right? Primarily iSchools, as we call them, library and information schools, but also, for example, the program at NYU that's focused on film preservation and film and media preservation, to expand out the way that people are using this in education, because it's already being very widely used in a lot of educational settings where instructors are using it either to just let people know how to use the software or to familiarize you with the kinds of tasks that you can do in a Linux environment, for example, by running this in a virtual machine, right? That's one of the very convenient things about this, is that if you can get VirtualBox and the extension pack for it and download and install it, which is all elaborated in that quick start guide, you can start using this software and playing around with it on your own computer without having to pay a license or get permission from anyone, right? So that's one of the reasons that it's used a lot in education, but of course there are also reasons why we want to be able to compare notes and sort of see, you know, lessons that instructors have learned about how best to implement it in different classes. So I hope that's a good answer to your question, right? I think there are a lot of different ways to get involved, some of which are fairly low barrier. There's a little bit higher barrier if you want to explore your institution joining as a consortium member, but certainly I'm happy to talk to people about that as well. It's been exciting to see it grow, right? Because at first it was just a few members coming out of the original project. We now have members from Australia, Canada, UK, the US, right? It's continuing to grow every year.
That was a fantastic answer. Thank you so much. And
Sure.
I noticed that Lee is on the call from the National Museum of American History.
Oh, yeah.
And that's one of the institutions that was on your list. So,
right.
Lee, I don't want to put you on the spot, but do you have any experience with it? And perhaps if anyone here has questions, they could get in touch with.
Yeah, and I would say also, Lee, if you're not able to answer, if there's anybody who can't do audio, feel free to throw questions into the chat too, because I'm looking at that. So if that's an easier way to ask questions or share comments. I realize sometimes people are in a space where they can't do audio as easily as they can do the rest.
For sure.
Yeah, so Lee is saying that she can do the chat. Okay, sorry. So yeah, so how does the Read PST tool work? So there was a question about one of those tools that I had listed there. Essentially what it does is you point it at a PST file, right, which is one of these files that has like all of your account information, your address book, your calendar items, your email in terms of folders. And then it just has various settings for whether you want to export everything as one big file, whether you want to export like out into, you know, folder structure that reflects the original folder structure of the person's email. So a lot of the additional processing on top of that, if you wanted to do some kind of searching or processing, would require other tools. Read PST itself is primarily just a pretty good tool for pulling stuff out of the PST so that you're no longer dependent on that format. We're actually using something called libpff, which is another open source tool for dealing with PST files. in the Raytom project that I just mentioned, which is looking at email. So it's conceivable that we might end up, including libpff as a set of tools within the BitCurator environment as well, if we find that, there are ways in which it can support activities that rePST can't. But it's basically just to pull stuff out of PSD files, right? So if you get stuff in that form, which very often institutions that get email from people end up getting it in that way, right? Somebody just basically gives you a file. It's a big, huge file that has all their email in it. And rePST is a set of free, component tools that will allow you to pull stuff out. And I also, as I was saying, there's documentation for the BitCurator environment itself in the Quick Start Guide. We are obviously not in a position to elaborate the documentation of every one of the component tools, and a lot of them already have their own documentation. So for example, if you just do a quick web search for rePST, you can find out a whole lot more about it because it has a lot of its own documentation. So the learning curve, and again, Lee, if you type something in as a response to that question, I'm happy to kind of read it out to everybody for those who can't see the chat. But in terms of the learning curve, right, and thoughts on biggest roadblocks, I think a lot of that roadblocks might be institutional, just in terms of getting the institution to commit to doing this sort of work, taking it seriously that, getting stuff off of disks is not the same as dealing with analog materials, so it requires support for different types of software. One of the ways that you can get around that to some degree, at least in the short term, is by running it in a virtual machine, because as long as you can run VirtualBox, which in many institutions is an easier sell to your IT support than something more complex and specific, you can run it in VirtualBox, you can start using it, seeing how it's going to work in your institution, and then if you find that it's really something that you want to launch into fully using on a daily basis, you could come back and say, well, we'd really like to actually run it as the operating system on a dedicated computer, and elaborate the reasons why that's helpful. In terms of learning curve, it really does depend a lot on how much of the functionality you want to use, right? It's a complete operating system. So in the same way that becoming an expert on Windows or something, right, could take you years, there's a lot of really powerful functionality built into Linux that can be used to, search over and compare strings of text and do all kinds of things that might require some more expertise. Some of the tools that are in the environment are command line only, so you'd at least have to have some command line understanding. But that basic set of tasks that I just ran through, creating a disk image, generating those reports, and then being able to review those basic reports. My experience has been, I do this quite frequently. I teach sort of 1 to 2 day workshops. And people can come from essentially zero in the sense they haven't used the software before to being in a position to actually go back to their institution and use it, right? It doesn't mean they might not have to start up slowly as they remind themselves of what they got exposed to in the training, but it really is, we've customized and designed the environment as well as we can to have a graphic user interface, so you can kind of walk through and click and select files in a way that doesn't require you to be, a computer scientist or a Linux guru in order to use the basic functionality. But that's not to say, again, that there isn't a lot more powerful functionality that you might really want to use that will take a little bit more time to learn, right? So it depends on what you're doing with it. For the basic functionality, I would really say, a couple days of intensive training usually puts people in a pretty good position. Of course, it does depend to some degree on your level of computer proficiency already. For people who are a little bit tenuous about, sort of even clicking on new tools and using things in a new environment, it might take a bit longer, right? So we've got this listing, sorry, from Lee saying it's a 6-month trial membership with BitCurator. Started using it a few months ago, have not yet installed it. So this is one of the things, this trial membership is also that we did this special thing this year where several institutions joined at this kind of reduced rate for a part of the year to try out membership. And yeah, so the things that Lee has elaborated reflect a lot of what happens when institutions are first starting to get involved, right? Seeing if this really advances the work that you want to be doing, looking at specific kinds of materials that it might help you to process, also looking at how it can identify personally identifiable information. The two really basic things that people tend to do almost always when they're using the environment are creating disk images It's not required. You could pull all the files off a disk and still use some of the other tools, but the other being bulk extractor, that tool for looking for PII. Bulk extractor, and I can't be, claiming some kind of glory for it on our team because it's a tool that we've borrowed from the original developer named Simpson Garfinkel, but it is extremely fast and scalable. It can run against very large data sets and much more quickly find those potentially sensitive information like credit card numbers, social security numbers, than almost any other tool that you might encounter. Like if your institution is doing regular scans over people's disks to see if you have PII on them, I can almost guarantee you that it runs dramatically faster than those tools because of the way it works. It's just going through and reading the underlying bits on the disk. It's not having to go file by file the way a tool would on your desktop. And so a lot of institutions use bulk extractor. If it turns out that that's the only thing that you really end up wanting to use, right? Nothing else in the environment is really of particular utility to you. You could simply use the bulk extractor software outside of the BitCurator environment, right? Because there's, for example, a Windows version of bulk extractor that you can run. So, so I hope, I presume most of you can read the chat to see Lee's full comment, but if people have any, follow-up questions or thoughts about that.
Awesome. Thank you so much for joining us, Cal.
Yeah, and so, yeah, I would just conclude by saying, obviously, if you have questions, feel free to follow up with me. And also, either just sort of lurk on the user list if you're curious what people are talking about, or also if you have a specific question that doesn't seem to have been answered on that list, feel free to post them, right? It's a very open community and people are generally pretty understanding and responsive to the newbies because we're all newbies in different ways, right?
Definitely. All right. Well, this whole session will be posted, like I mentioned. We've recorded it, so feel free to come back to it at any time too. And with that, I think we can let you go ahead with your day. We have a little bit of meeting wrap up to do.
Yeah, sounds great. Well, thank you very much. It's great to sort of meet everybody, right?
Yeah. Thank you. Bye.
All right. Bye.
So, I hope this was helpful. Next month's meeting is going to be on June 26th, same time and same call-in info. We're already halfway through 2019 somehow, so I think the meeting is going to be just a time where we can pause and talk about things that are happening at your institutions and to chat more informally as a group about things that you want to share, any questions that you may have for colleagues, anything that you want feedback on. Feel free to bring that to the meeting. And we've got a couple people who have already requested some time to talk about things. Our colleagues at the New Museum are going to share features from their digital archive that they're really excited about and sort of ask for feedback on that. But if there's anything else that you think of, just go ahead and add it to the future topics for next month at the bottom of this month's agenda. So is there anything anyone wants to share this month about what's happening at your institution? All right. In that case, we'll catch you June 26th, and thanks so much for joining. Bye, everybody.